Young. My metric number is 198369. Now I want to discuss on the assignment one. Now I want to discuss on the fluid characteristics and the dimensional analysis. Fluid characteristics. Fluid is defined as a substance which can flow. Technically, the flow of any substance means a continuous relative motion between different particles of a substance. Types of fluid. The term fluid includes both liquid and gases. The main difference between the liquid and gas is that the volume of a liquid remains definite even it takes the shape of the surface on or in which it comes into contact, whereas a gas occupies the complete space available in the container. Viscosity. Viscosity is a fluid property that determines the amount of resistance of the fluid to shear stress. The liquid viscosity decreases with increase in temperature. In gas, viscosity increase with temperature. Increase with increase in temperature. Density is the mass volume of a fluid. And this is the formula of the density. The specific volume. Specific volume of a substance is a ratio of the substance volume to its mass, and this will be its formula, and it's the reciprocal of the density, and we can use the formula of P equals to nRT to find the volume. Specific weight. Specific weight, also known as the unit weight, is the weight per unit volume of a material. The symbol of the specific weight is gamma, Greek letter gamma, and commonly used in water on Earth at 4 degrees Celsius, which is 9.807 kilonewton per meter cube, or 62.43 pound per feet cube. Specific gravity. Specific gravity is a ratio of specific weight of a given fluid to the specific weight of standard fluid, and this will be the formula of the specific gravity. Dimensional analysis. Dimensional analysis is a means of simplifying a physical problem by appealing to dimensional homogeneity to reduce the number of relevant variables. For example, the dimensions consist of m, l, and t. M stands for mass, L stands for length, T stands for time. It is helpful in experimental work because it provides a guide to factors that significantly affect the studies of the phenomena. In particular, useful for presenting and interpreting experimental data, attacking problems not amenable to direct theoretical solution, checking equations, establishing the relative importance of particular physical phenomena, and lastly, physical modeling. There are two methods to do dimensional analysis. One is the Rayleigh's method. One is the Buckingham's pi method. This will be the table for the dimensions. This column will be the quantities. This column will be the common symbols. This column will be the dimension. Dimensions consist of n, l, and t, which are mass, length, and time. And now I want to talk about the Rayleigh's method. Rayleigh's method is a form of dimensional analysis. Dimensional analysis expresses a functional relationship of some variables in the form of exponential equation. It was named after Lord Rayleigh. This method involves following steps: gather all the independent variables that are likely to influence the dependent variable. If R is a variable that depends upon independent variables R1, R2, and R3, and many more, then the functional equation can be written as R equals to the function of R1, R2, R3, and the following equation. The third is write the above equation in the form of R equals to constant R1a to the power of a, R2 to the power of b, R3 to the power of b, and so on. Where C is dimensionless constant and A, B, C, and so on are the arbitrary exponents. Fourth is express each of the quantities in equation in some base units in which the solution is required. By using the dimensional homogeneity, obtain a set of simultaneous equations involving the exponents a, b, c, and so on. Number 6 is solve this equation to obtain the value of exponents a, b, c, and so on. Substitute the value into the original equation is the last step. So this is the one real example on Rayleigh's method. Uh, uh, from this question, a partially submerged body is covered in water. The resistance R to its motion depends on the density. This is, if I can say, is P. The velocity, the viscosity, a symbol is like that, of water length, velocity of the body, and the acceleration due to gravity. Show that the resistance of motion can be expressed in the form of this one. So, firstly, we have to find whether it's what is the dependent variable and what is the independent variable. So the dependent variable will be R. The independent variable will be the others. This symbol. And the second step we have to do is we have to put this whole equation into this equation, the whole variable, the all the variable into this equation, including the constant. The constant will most likely have uh, all the dimensions with a power of 0. So m to power 0, l to power 0, and t to power 0. And this is the third step, we have to find all the dimensional variables for these variables. And we sub into this equation, which is this equation. Then we find the value for each letter, like A, B. So we find A and D for M and T. So after find A and D, we sub into this L equation so that we can find C equals to 2 minus P plus E. So after that, we just sub into this R equation, sub, and then just do, and then we can find this final equation proven. Next, we are going to I want to talk about the Buckingham's pi theorem. Buckingham's pi theorem states that if there are n variables in the problem, this variable contain n primary dimensionals. For example, MLT is the equation. In the equation, treating all the variables with has n m dimensional groups. Buckingham refers to this group as pi groups. The final equation obtained in the form of pi equals to the function of pi 2, pi 3, and so on. The pi groups must be independent of each other, and no other groups should be formed by multiplying together powers of other groups. This method offers the advantage of being more simpler than method solving simultaneous equation for obtaining the values of the indices. Okay, so this is the example that I want to show you. The problem is Fd is a function of viscosity, velocity, mass density, and diameter of the sphere for fluid flow. So first step, we have to identify the relevant variables, which is Fd, this one. And the step 2, we have to find all the dimension of the variables. Step 3, we have to find the number of variables, which is 5, 1, 2, 3, 4, 5. The number of independent dimensions is 3, independent, which is M, L, and T. So we have to find the difference between these two, and the difference between these two is the number of non-dimensional group, which is 3. So we choose 3 repeating variables. So I choose from here P, B, and D. So after searching for P, B, and D, we have to create the pi non-dimensional of the remaining variables, which are FD and this one, viscosity. So after searching for this one, we in pi 1 FD, then we find out that the value of M is x equals to -1, value of Ly equals to -2, t equals to the value for t is z equals to -2. The pi is this is the new formula for pi 1, and this will be the formula for pi 2 as we put in this one, this viscosity in the in this one, uh, in the remaining variables, this one we add on this one so that we can find out the new formula. So After that, we set out the non-dimensional relationship. Pi 1 equals to function of pi 2. Then we substitute all and we found this equation. Buckingham's pi theorem will let us find the equation until here only, but not so on. Thank you.